This month's Master Tech session is on the new Chrysler Corporation electronic ignition system. We'll cover the basic fundamentals of how it works compared to a breaker point ignition and the complete diagnostic and service procedures for the system. For this session, I've lined up Tom, who's a real ace when it comes to breaker point ignition, and also has the complete lowdown on the new electronic system. Bud, one of the younger technicians in the dealership, asked if he could sit in on the session.
If you remember, Bud, electronic ignition was first introduced as a running change in 1971 for the 340 engine equipped with a manual transmission. For 1972, it has a much wider application both as standard equipment and as an option. In California, it will be standard equipment on all 8-cylinder models. But before I go any further with the electronic system, I want to review the periodic service required with a breaker point ignition so that you can fully appreciate the advantages of the new electronic system. The present breaker point ignition system has been steadily improved and has become an excellent system. However, of all the breaker point ignition components, the points themselves have the shortest service life. Let's see how point life affects engine performance. First of all, because of point contact burning and rubbing block wear during normal service, the point gap will start to close. I'm sure you know that a narrow point gap will retard engine timing and increase the distributor dwell. Even when kept properly adjusted, deterioration of the breaker points due to metal transfer, oxidation, and erosion will eventually cause misfiring. Continued misfiring, caused by breaker point deterioration, will also cause carbon deposits to form on the spark plugs and considerably shorten plug life. Unfortunately, we're well aware that the average owner does not have a tune-up performed often enough to prevent or even correct misfiring. With the electronic ignition system, periodic distributor service will be a thing of the past, since the breaker points and cam have been replaced by electronic circuitry.
Hey, that looks just like a breaker point distributor housing.
The distributor housing and its advanced mechanism, the rotor and the distributor cap, are the same for the electronic system as for the breaker point system. And both systems use the same ignition coil and spark plugs. The ballast resistor is slightly different. We'll cover that later. Inside the electronic distributor, most of the setup is brand new. A pickup unit consisting of a permanent magnet and a coil that is wound around a pole piece attached to the magnet has physically replaced the breaker points. You'll notice that the condenser is no longer there either. The reluctor has one tooth for each cylinder. The reluctor performs the same function electronically in the new system that the cam and rubbing block do mechanically in the breaker point ignition system.
I don't understand how that reluctor can activate anything. It looks to me like it doesn't contact at any time.
I'm afraid the first thing you better understand is that there is no contact by the reluctor, and the pickup unit is not a set of points. Let's review how breaker points work. Then I'll explain how the pickup unit and reluctor do the same job. In a breaker point ignition, the current flowing through the primary winding of the ignition coil is interrupted when the breaker points are opened by the rotating cam. The collapsing magnetic field in the ignition coil primary induces enough voltage in the ignition coil secondary winding to fire the spark plugs. In the electronic system, the permanent magnet provides a magnetic field at the pole piece and the coil. However, it is a relatively weak field with a wide air gap between the pole piece and the reluctor tooth because the air gap offers resistance to the field. As a tooth of the reluctor approaches the pickup pole piece, the air gap becomes narrow. This provides a better magnetic path and creates a stronger magnetic field. Increasing the field strength induces a positive voltage at one terminal end of the coil. As the reluctor tooth passes the pole piece, the air gap widens again and the magnetic field weakens. The decreasing magnetic field strength at the pole piece induces a negative voltage at the same terminal of the coil.
I think it should be stressed at this point that it's the rapid increase and decrease in the field strength caused by the rotating reluctor that induces voltage in the coil. When the reluctor is not moving, the magnetic field is constant and no voltage is induced in the coil. Remember, it's the movement that causes the positive then negative voltage.
Is the changing pickup voltage the same as the primary current being interrupted by open contacts?
Not really. It's only a signal for the rest of the circuitry. What it really does is trigger the control unit. Here's how the control unit works. In the electronic ignition system, battery current flows through the ignition coil and then through the control unit, which is grounded to maintain current in the ignition coil primary winding. The pickup voltage is also fed into the control unit. When the pickup voltage to the control unit is negative, it deactivates or turns off the control unit circuitry. At this point, current will not flow through the control unit to ground, and therefore the current through the coil primary is interrupted. The control unit circuitry also controls how long the primary current is interrupted and therefore determines the dwell. Since the control unit is sealed, the dwell cannot be changed or adjusted. Here's what the circuitry looks like before it's sealed.
Can the dwell in the control unit be read with a dwell meter?
A dwell meter connected to the electronic system will give a reading. However, the design of the control unit circuitry is not compatible with the dwell meter, and the reading on the meter will be inaccurate. So a dwell meter cannot be used for performance analysis purposes on the electronic system.
The way I see it, the reluctor and pickup unit control the timing, and the control unit determines the dwell independently. However, it takes both of them working together to actually interrupt the ignition coil primary current and fire the plugs. Now, how about some tips on checking the system if you have performance problems?
If you get a performance problem, the first thing to check in the ignition system is the rotor and distributor cap for cracks or corroded contacts. Hairline cracks are sometimes difficult to see, so look the cap and rotor over very carefully. Visually inspect the secondary ignition cables for loose connections and check their performance with an ohm meter or an ignition oscilloscope. Then, check the spark plugs and re-gap or replace them if necessary.
How about checking the electronic components?
Special Tool C4166 is an electronic ignition tester that is used to check the primary circuit components and wiring. It's an essential tool in troubleshooting the system, and it's very easy to use. With the ignition switch off, remove the screw and disconnect the wiring harness from the control unit. But leave the dual lead from the distributor hooked up. Connect the female connector of the tester to the control unit and the male connector to the wiring harness to put the tester in the ignition system circuit. At this point, disregard the dual wire tester lead and battery clips. Turn the ignition switch on, but don't start the engine, and observe the tester. If both green lights come on and all the red lights remain off, this indicates that all components and wiring in the primary circuit are good. To check the secondary, disconnect the ignition coil secondary wire from the distributor cap and hold it close to a good ground. Actuate the high voltage coil test switch and observe the spark between the wire and ground. Pull the wire away slowly until the spark stops. When the spark stops, closely observe the coil tower to make sure that no arcing across the tower occurs at this time. If no arcing occurs, this completes the testing and indicates a good ignition coil.
If arcing does occur at this point, then can I assume the trouble is either in the coil or in the secondary cables?
Yes, Bud. Check the coil according to the procedures and specifications in the service manual, and check the cables with an ohm meter or scope, as I mentioned earlier. If the green light labeled ignition input voltage does not come on, it indicates that the input voltage is not high enough for the tester to operate. First, make sure that the battery is fully charged. If the battery's okay, check the battery terminal connections. Make sure that the control unit is properly grounded, and check the ignition switch and the wiring to and from the switch. If the control unit light does not come on, the control unit is faulty and must be replaced. Each test light is completely independent of the others, and if the control unit is good, the light will be on even if there's a fault in the pickup unit, primary circuit, or the dual ballast resistor.
Won't a red light come on if the ballast resistor is bad?
Yes. If the red light labeled auxiliary ballast circuit comes on, the dual ballast resistor must be replaced. The 5-ohm auxiliary side of this dual ballast resistor protects the control unit, the same as the half-ohm side does for the ignition coil primary. If you have to replace one of these units, just make sure that the lead connectors are correctly installed.
Speaking of sides, we'll have to go to the other side of this record to continue Tom's excellent lesson. Will someone please turn the record?
If the primary circuit light on the tester comes on, check the ignition coil primary, the suppression capacitor, half-ohm side of the dual ballast resistor, and the wiring harness for an open in the circuit. If the pickup circuit light comes on, the pickup unit or wiring is faulty and must be replaced. Even if the light does not come on, it's a good idea to flex the wiring from the pickup unit to double-check it. If the red light blinks while doing this, the wiring is bad and the unit should be replaced. One more thing. This tester is equipped with a circuit breaker to protect it from overloading when testing a shorted control unit. If the circuit breaker opens, wait 1 full minute before resetting the circuit breaker and continuing testing. Incidentally, the input voltage light must remain on through all tests. If it is not on, the input voltage to the analyzer is not sufficient, and any reading on the light panel cannot be accepted as being accurate.
I'm sure the fellas are as curious as I am about why the other test lead and the clips weren't used. Want to tell us about them, Tom?
Sure will, Tech. Those, along with one of the control unit test leads, are used to bench test the pickup and control unit. Hook up the clips to a fully charged battery with the red clip on the positive pole. To test the pickup, connect the tester lead to the pickup wiring connector. If the red light comes on, the pickup is faulty and must be replaced. When bench testing the pickup unit, the control unit light will be off and the primary circuit and auxiliary ballast circuit red lights will be on. That's because there is no input for these components into the tester. When bench testing the control unit, all 3 red lights will be on because of the same reason. So you only need be concerned with the input voltage light and the light for the component being tested. To bench test the control unit, simply plug the 5-pin female tester lead into the control unit. If the light does not come on, the control unit is faulty and should be replaced. And that completes the testing procedures using tool C4166.
I noticed there's an adjusting slot on the distributor plate which looks like it can change the gap between the reluctor and the pickup. Can't the dwell be changed by narrowing or widening the gap?
No, it can't. Remember, in the electronic ignition system, dwell is independent of the pickup gap, so adjusting the gap does not affect dwell or timing. But it should be properly set. One of the main advantages of the electronic system is improved starting, because with no points, the possibility of arcing across the points at starting has been eliminated. However, a pickup gap that is too wide can defeat this purpose and cause starting problems. Here's what happens. As the air gap between the reluctor and pole piece increases, the resistance to field movement increases. Along with the low cranking speed of the reluctor, it becomes more difficult to induce pickup voltage. This condition can cause hard starting. In fact, you can even end up with a no-start condition if the gap gets wide enough. So if you get one of these conditions, the pickup gap may be at fault. However, make sure that the fuel system and the rest of the ignition system are okay before adjusting the pickup gap.
Of course, setting the gap is a must when installing a new pickup unit. To do this, insert an 0.008 feeler between the reluctor and pickup pole piece. Tighten the pickup adjusting screw. When properly adjusted, there should be a light drag when you pull out the feeler gauge.
You'll have to use a non-magnetic feeler gauge because a feeler gauge that is attracted to the magnetism of the pole piece would not give the proper feel. A piece of brass shim stock would be ideal for this purpose. After resetting the gap, Run the distributor on the test stand and apply vacuum advance. As the distributor advances, make sure that the reluctor teeth and the pole piece do not come into contact. One other thing. The reluctor tooth may appear to you to be a little rough on the edges. Do not try to file the edge of the teeth, or you may round the edges of them. A sharp edge is needed to quickly decrease the magnetic field and induce the negative voltage. If the teeth are rounded, the signal to the control unit will become erratic. You'll also notice two small arrows on the reluctor in opposite directions. In a clockwise distributor, the arrow at the keeper pin on the reluctor should point clockwise. In a counterclockwise distributor, it should point counterclockwise at the keeper pin. If the arrow at the keeper pin points in the wrong direction, remove the reluctor, turn it 180 degrees, and reinstall it. While doing this, be careful not to lose the keeper pin.
Do the different colors on these control units signify anything?
Sure do, Bud. There are 3 different control units. As you can see, there's a gold one, a blue one, and a red one. The blue and red units are equipped with a speed limiter. The speed limiter is an additional circuit that is built into the control unit to limit the RPM range on certain engines. The circuit causes the control unit to become inoperative if the RPM limit is exceeded. The red one will limit the RPM range to between 5,000 and 5,200. The blue one will operate in the RPM range of 53 to 5,500.
If any of you technicians replace a control unit, make darn sure that you install the proper control unit for the particular engine you're working on. The part numbers and model application will be in the reference book for future reference.
I want to give a little warning about that control unit. This little round unit on the front is the switching transistor. That's the one that's connected to ground and interrupts the current in the primary circuit when it turns off. Don't touch it while the ignition is on. It can give you a pretty good jolt.
Hey, are these bright orange cables something new for the electronic ignition system?
Those are the new silicone rubber covered secondary cables. They are new and they are standard equipment on the electronic ignition system. They're also available as a replacement item.
Chrysler Corporation hasn't used metallic conductor cables for about 10 years and now has agreed with the Federal Communications Commission to take it out of their parts department altogether. And the corporation is asking you technicians to help out by refraining from installing them on any customer's car. Metallic conductor cables contribute substantially to what is known as radio frequency interference. In simple terms, this means that it can interfere with other forms of communication equipment. The greatest danger lies in interfering with community service vehicles such as police cars, fire trucks, ambulances, and the like.
Right, Tech. Metallic conductor cable does not result in better ignition or a hotter spark than the cable which is standard production equipment. It isn't any more durable and won't last any longer either. The new cable is equipped with a silicone rubber outer covering that has high flexibility and is extremely heat resistant. A fiberglass jacket also has been added which increases the strength and durability over the neoprene cable. Otherwise, it's essentially the same. At the terminals, the stranded conductor has been wrapped back over the outer covering and the clip installed. This new construction provides a positive connection with sufficient contact for a good, strong spark.
That doesn't mean that you guys can start using the cable as a handle for disconnecting it. The only thing you'll disconnect that way is the cable from the connector. Always remove the cable from the plug by grabbing the terminal itself. The cover is flexible enough for this to be done with ease.
Another new item you'll find on some 72 models is the distributor advance solenoid. It advances spark during engine cranking only. It will advance the spark approximately 7.5 degrees. The reason for the advance is to improve starting. Once the car is running, the power to the solenoid stops and it becomes inoperative. To check the distributor advance solenoid, you'll need full battery power. So get a jumper wire long enough to reach the battery from the solenoid. You'll also need a tachometer to check engine RPM. To test the distributor solenoid, connect the tachometer, Start the engine and run at idle. Disconnect the vacuum line at the solenoid. The lead wire cannot be removed at the solenoid, so disconnect it at the connector, which is about 6 inches from the solenoid. Connect a jumper wire from the distributor solenoid lead to the battery. If the tachometer indicates an increase of approximately 25 to 50 RPMs, the solenoid is good. Since the solenoid is not designed for full-time operation, don't keep the jumper on for more than 30 seconds. Otherwise, you'll burn it up. Now, when...
I hate to cut Tom off, but we're just flat out of time. If you read this month's reference book, you'll find an extensive explanation of why the electronic ignition system is superior to the conventional breaker point system. Along with your reference book, you'll find some more Tell It to Tech forms. If you have some suggestion that might improve serviceability on our cars or trucks, fellas, tell it to Tech. Send in your suggestions to me on one of the forms enclosed with this session. Thanks, and see you all next month.